Okay, can you see the screen which is shared?
Yes, sir.
Okay, so in the last class, we discussed about hyperparameters and how changing the different hyperparameters can affect a model. Now, today we're going to look into an example and see and work on a regression classifier, okay, or regression model. To do that, we're going to make use of a very popular library in Python called as Scikit-learn. There are many other different libraries which can be used for machine learning approaches, but Scikit-learn is one of the most popular libraries, which has all these different features and a very streamlined API or a very good pipeline for which we can perform these different operate or perform any kind of machine learning applications. Okay, given some data, I can pre-process the data. After pre-processing the data, I can fit the data, build a model, and using that model, I can make predictions. Okay, so it has a very good pipeline which we can make use of to for machine learning applications. Okay, so Scikit-learn is if you just go to your browser or like 1 minute. Yeah. You go to a browser, you can type, if you can type in just Scikit-learn, Google Scikit-learn, the first link that you get goes to the homepage of Scikit-learn, which has all the different algorithms for machine learning. If you look at the classification algorithms, you have all ensemble, non-ensemble models, various different models which we're going to discuss in this particular course. And we also have different regression-based model, clustering-based model, supervised, non-supervised based model, and many all these all pre-built over here. So there is very little coding. Just by tweaking the various different hyperparameters for each and specific model, we can train or make predictions given some data. Okay, so it is a very large library which has a lot of features. That is, if you go into the API itself, if you look on the API itself, you can see the different parts. It has the many classes that it has. So, for example, today we're going to look into linear regression. So, all the algorithms, all the estimators, which is called in Scikit-learn, that is the different algorithms, machine learning algorithms in Scikit-learn are named as estimators, or it is termed as estimators. Okay, so all these estimators are basically different classes defined inside this library. Okay, within this Python library are various different classes. So one such class is, let me just command F, see where I can find it in this particular page. That is linear regression. Yeah, linear regression is here. Fine. So this is a class that we're going to use where we already learned linear regression, the basics behind this. So this is a class which is defined within this particular library. Okay, within another module called a linear module. There's a class called linear regression defined, which takes in a few parameters, and these parameters over here are my hyperparameters, which I can change to improve my model in some way or not. Okay, so this is a very simple linear regression is a very simple model. We cannot do much with that, but this is just a starting point where we're going to learn various other modules. Okay, so we're going to use Scikit-learn, and I have this notebook prepared for you, which you can make use to learn later on. Also, I will be sharing this notebook to you also. Okay, so to start off. Okay, to start off, we need data, right? The first thing that we need to demonstrate, say, linear regression, we're going to look into linear regression now. The first thing that we need is data. Okay, so data, you can either get data from public data repositories. You can go to Kaggle, get data, or there are many other different repositories where you can get data. But these libraries, for example, Scikit-learn. Okay, so if I go to Scikit-learn and again look at particular data sets, okay, you can see there are some data which is already there within the library itself, which which has data stored in a particular format. Okay, it can be a pandas format, it can be a different format for the library itself. But for each type of library, there is a different type. Similarly, there's another library called as Seaborn. Okay, we're going to use another library called a Seaborn. Seaborn is basically built on top of Matplotlib. Okay, I think you all are aware of what Matplotlib is. So it is used to visualize data, and you must have already learned that. Seaborn is another library which is built on top of Matplotlib, which makes plotting graphs or data much more easier. Okay, this Seaborn library also provides you with data sets. Okay, very small data sets that can be used for prediction. Okay, prediction for educational purpose, for testing out various different models, for comparing various different models and understanding what it is. Okay, so over here in the first, I'm going to show you two examples. In the first example, I'm going to make, or in the first way where I'm going to discuss Scikit-learn and how we can make use of the Scikit-learn API to make predictions or make use of various machine learning models, which is defined inside Scikit-learn. We'll use Seaborn for that. Okay, initially, and then later on we will look into a real world example. And in this real world example, we will make use of the data sets defined inside Scikit-learn itself. Okay, so this library is Seaborn. We can load data sets from the, for example, you can see over here. To import Seaborn, I used to make use of this particular library. I used the import statement, import Seaborn as SNS. You can give any areas over here instead of typing Seaborn every time to make my coding a little more shorter. I can provide any kind of alias. So this is a meaningful alias which is commonly used whenever you are importing Seaborn. Okay, by calling a function called load data set inside the Seaborn layer, you can load different types of data sets. One such data set is iris. This is a very small data set. Okay, so if I run this particular code and if you look at the type of iris, something went wrong. Yeah, it's running now. So, okay. So some network issue was there, so that I was not able to load a data set, but now I'm getting it. So if I look at a type of iris, whatever data set the Seaborn has, when it loads this data set into this reference variable called iris, if I look at a type of it is nothing but a data frame. Pandas data frame. So the data which is loaded using the Seaborn library is nothing but a pandas data frame. Okay, so if you look at this, like, if you, those who hope you know that, I hope you all are aware about pandas. And using pandas data set, if I want to if you know the first to return the first few rows of my thing, I can use what iris dot head, and this will return the first 5 rows of within my data set. I can see we'll have a small idea what this data set is. So it is as it's iris is basically flower, different flower types. Okay, and basically the length of the sepal, the length of the petal. Okay, all these based on that, what species of iris flower it is. Okay, iris is a type of flower. What species does it belong to? That is a prediction that we are trying to make using this particular data set. We have not discussed classification at the moment. We have discussed only regression. I've just showed you this because we can, I'm just telling you that we can also load various small data sets. So this is data set which is very small. So this is say 150 flowers. If you look at the next code which I have over here, which will give you a little more extra information about the data that I have or about the data frame which I have. So you can see over here, I have 150 non-null values. So basically I have 150 different examples or samples, okay, of my data. And based on these samples, I can train my model and make predictions or find out, given a new flower with a particular petal length or a particular sepal length and a width, I can identify which type of species it belongs to, or I can predict which types of species it belongs to. Okay, so using the Seaborn data set, I can load such data sets. Now, once I have a data like this, okay, once I have a data that, how can I make use of the Scikit library, or if I have any data as a data frame, Okay, how can I make use of the Scikit-learn library to actually make some predictions? Okay, that is what we're going to look next. Okay, so to understand this, one thing we need to know is we need to consider our data in forms of a matrix. Okay, so I have this data, consider this as a matrix. Okay, where I have rows and columns. Okay, rows and columns. That is what I have, right? So once I have that, the number of rows or number of samples that is there in my data set, number of rows, I'm going to term this in this particular notebook as n samples. That is the number of rows, and the number of columns are basically the different features. I'm going to name it as n features. Okay, over here, the last feature. Okay, the last feature is basically my target value. Or I can say that is a dependent value. Okay, based on, so when you're talking statistically, when you're talking is, the last one is a dependent variable and the others are independent variable. So I'm trying to predict the dependent variable given the independent variables. Okay, so I have n samples or my data set has n number of examples or samples, and each data in my data set has n different features. Okay. And for every data, you should have two things. The first thing is a feature matrix. Okay. And the second thing is the target array. So two things, a feature matrix. So when you talk about matrix, a matrix is always two-dimensional. Okay. So you should have features which should be two-dimensional. Even if you have only a single feature, okay. So if you're going to perform some kind of regression or classification model using a single feature, it still should be two-dimensional. That is, it should be a matrix with n number of rows and one column. Okay, it should be two-dimensional. So you should have a feature matrix and the target array, and the target array can be single dimension, it can be also more than single dimensional also. So we're not going to discuss when it is more than single dimension. We're going to discuss only in the case where when your target array is always a single array, you want to predict a single value given a set of features. So you have a set of features in your feature matrix, and you need to predict a target array, or you need to predict what would be the target value if so and so features are provided. Okay, so that is the basic idea. So in our example over here, can someone tell me what are the feature metrics and what is my target array? Which are my which constitutes my feature metrics and which constitutes my target array? Okay, so over here we have 1, 2, 3, 4, 5 columns. So over here, the independent variables, all the independent variables, which is the sepal length, the sepal width, the petal length, the petal width, all these would contribute to my feature metrics. And the target array is what I need to predict. The target array is the column which I require to be. So the species is the column which I need to predict given a sepal length, a sepal width, a petal length, and a petal width. I need to predict the feature. So the species column becomes my target, and the other columns goes to my feature metrics. Okay. So I have my feature metrics and my target array. Okay, so given this a single data frame, I need to make sure that I separate both this. So you have your data. If I want to pass this data into any machine learning algorithms that is defined inside Scikit-learn, you need to make sure you have your feature metrics separately and your target area separately. But currently my data, everything is together, right? Everything is together as a single data frame. So I need to separate this. So that is what I'm going to do next. Okay, so I'm going to separate this as a feature matrix. So to get a feature matrix, what I do, given the whole data frame, I have dropped the column species and created a new data frame called as X. X is my features. So X underscore iris. And I also what I put in the shape of my data frame. Okay. So basically I have 150 examples and 4 columns. So 4 columns are basically the 4 features that I have. That is, again, going back to the database, the sepal length, the sepal width, the petal length, and petal width are the features. Okay. So I separated my, from my original data set, I've taken out my feature metrics alone. Okay. All my independent variables alone. How do I do that? By dropping the species column. Okay. Now, how do I get my target metrics? To get my target metrics, what I do, I extract only the species column. Okay, I extract only the species column from my iris data space. So iris species column will give me my target metrics. So that I will name it as y underscore x is my features and y is my target weight. So y is what I need to predict. X is the features that I have. Okay, so y underscore iris is my target. Okay, target, it's not a target metric, sorry, it's my target array. So this should be an array. So when I extract only the species column, you can look at a shape which I get, it is a single dimensional shape. I have only one dimension, and that one dimension, 150, I have 150 examples. Okay, I have 150 examples. That is, if I just Yeah, I have 150 examples. Now, once I have my data as a feature matrix, as a target array, next I can use any one of the estimators defined inside Scikit-learn, okay, to make a prediction or to build a model. I can use any one of the estimates. So what I mean by estimators of here are basically the various different algorithms that is defined inside Scikit-learn. So for here, as I told you earlier, one of those algorithms that we saw is linear regression. Okay, you can see linear model over here. Within linear model, I have linear regression. Yeah, linear regression class. Okay, so these are all various other, so logistic regression is another estimator. Okay, these are all different other estimators, or basically these are all different classification or regression algorithms that we can use to make to build a model based on the data that I have. So I have my data as a feature matrix, I'm a target array. Next, I can make use of any one of the estimators defined inside Scikit-learn. Now, how to make use of there are 5 different steps that we need to follow to actually make use of this API or to make use of any of the estimators defined inside Scikit-learn. The first thing is we need to do is we need to import an appropriate estimator class from a Scikit-learn library. Okay, the first thing we need to import. So for example, if we're going to make use of linear regression, I need to import the linear regression class. Or if I'm going to make use of, say, decision tree, okay, as an estimator, then I need to import the decision tree as the decision tree class into before I start anything. Okay, so based on which estimator that you want to use to build your model, you need to import the corresponding class from Scikit-learn. So that is step 1. Step 1 is just importing a class. Step 2 is to instantiate a class. Instantiate a class is nothing but to create an object of that particular class. Now, we don't simply create an object of the class. This is where we choose what are the values for the various hyperparameters or what are hyperparameters that we're going to use to build a model. So based on these hyperparameters, your model will be built. So it is based on these hyperparameters how good your model is going to perform. Okay, so the second step is to instantiate a class with providing values to the various hyperparameters for each of the different models. So for example, of your linear regression, if I click on linear regression, one of its hyperparameter is fit intercept. which by default is true. If I want, I can set as false. Okay, so what fit intercept is nothing but whether we should calculate the intercept for this particular model. So y is equal to mx plus c. That is linear, right? That is linear regression. So should I only calculate a coefficient m, or should I also update the bias value? Or should I only update the weight value? If I set this a fault, then intercept will not be used for any calculation. So data would be, so in those cases, it should be in the case where your data is centered. Only in the cases when the data is centered should we use fit intercept as false. By default, you will always have your fit intercept as true. Similarly, you will have various different other parameters. Now, if you look at a different model, okay, let's look at a different model. Let's look at decision trees. Let me find where this is a linear model. So naive bias is then, okay, tree. There is a decision tree classifier. Okay. Now, if you look at a decision tree classifier, there are plenty more other hyperparameters that we can change to make sure that I build my model based on the data that I have. For example, what is the maximum depth of a tree that I can create? Okay. Then minimum split value, the minimum samples for each leaf. Okay, so that there are many such hyperparameters. So every estimator that is defined in Scikit-learn has its own hyperparameters, and we need to, based on the algorithm that is it is used to implement, and we need to make sure that we find the best hyperparameters for the data that we have, so that we can build the best model. Okay. So that is the second step. That is more, you need to instantiate the class which we imported earlier in first step. Okay, and provide new hyperparameters. The third step is to arrange data into feature metrics and a target vector, which we already saw earlier, right? Given our data, you must have a feature matrix separately and a target array also separately. So that is the third step which we have in our thing. Okay. And next, after we have our data as a feature matrix and a target vector, we use a model class and call a function called fit to build a model. Okay, based on the hyperparameters we have set while instantiating the class. That is the fourth method. Once the fit method is called, the fit method is going to build a model based on the algorithm. Okay, build a model based on the algorithm, based and also based on the data that you have. Okay, once the model is built, next you can make use of this model to make new predictions for new data. Okay, so that is your fifth step. So for supervised learning, you will often predict labels and you use a method called as predict method. And for unsupervised learning, you can use both transform or predict method to actually to find out which cluster it belongs to or where the data should go. Okay. Now let's take an example. Let's take an example of a simple linear regression. Now over here, I'm not going to use any kind of real data. I'm just going to create some random data using NumPy. Okay, and using the random module of NumPy, I'm going to use some random data, and I'm going to try to build a model based on this random data. Okay, in the first example. So my data is like this. That is, I used NumPy. Okay, created some random values. Okay, and for every x value ranging from 0 to 50. Okay, 0 to 10. Okay, for every x value ranging from 0 to 10. Okay, so a random value is between 0 to 0 0.1. So for every x value ranging from 0 to 10, I'm generating some random y value here. Again, I'm generating some random y value based on an actually a linear equation. So it's basically a linear data set that I have. So I'm going to try to find having this data is basically linear because I use the linear equation itself over here. So my over here my coefficient is 2, right? This is my coefficient or my slope is 2, and my my y-intercept is basically -1. Or I can say my bias is basically -1. So I created a linear model and created some data, random data, so that it does not fit exactly in a straight line. It goes a little up and down over this particular. So I'm just randomly created. So here you can see the equation which I have where my slope is 2 and my y-intercept is basically -1, or my coefficient of my variable x is my what? X is my feature, and the coefficient of this particular feature is 2, and its corresponding y-intercept is -1. So I already have this model. This is actually a linear model itself, but I'm going to try to build a model using what? Using linear regression. Okay, I'm trying to build a model using linear regression given this data. I have this data, given this data, I'm trying to build it. Okay, so I'm just using the scatter plot to just to visualize and see that particular data over here. So you can see that since we're having a linear model with some random variations to the actual model, actual line, I have this data spread it across this particular line in a random way. Okay, so this is my data. Now I have my data. What is the first step? Let's go through each one of these steps. The first step is choose a class for this model. Since this is data is in a linear format, we can see that it is linearly increasing in almost in a straight line. The best model and the most simplest model that we can use is linear regression itself. So it's for showing the linear regression example. I've considered this particular data. So over here, I need to select a class which will help me create a linear regression model. For that, I use a linear regression class. So I need to import this linear regression class. Again, going back into my API, you can see that where is my linear regression class? So that is linear model. Maybe I think I lost it again. Yeah, linear model. Logistic regression, logistic linear regression. Yeah. Linear regression, you can see the linear regression class is defined inside a module called a linear underscore module inside the Scikit-learn library. Okay, so I need to import that first. Okay, so from my Scikit-learn library, inside the module called linear underscore module, I'm going to import the class called linear regression. Okay, first step done. Second, I need to instantiate an object of this particular class and provide us hyperparameters. Okay, and provide us hyperparameters. So in this case, there is not much in linear regression. There's not much. There's not much hyperparameters that we can play with. Okay, one thing is fit intercept, which we already know the default value is true. If you want, we can set the default value as false, but we set the default value as false only in the case when your data is centered in your axis. So this is not a centered data set. If your data is centered in this particular axis, you know that it is not. Yeah, this is also centered. So over here also you can still give false. So it is still centered. Okay, so when you know that your data is centered, then in that case you can give fit intercept as true. Okay, so if you are center, you can give fit intercept as false. Over here, I'm going to keep the default value itself. I'm not going to change any other hyperparameters. The idea of here is just how we are going to make use of linear regression to make a model and make some predictions. Okay, so model is equal to, this is how I create an object. I could use the class constructor, provide the necessary values for the necessary hyperparameters. Now, if you do not provide values, the default values will be taken automatically. Okay, and you build a model. Okay, now by printing the model, you can see this is the output of the model. That is nothing much different. There's no much hyperparameters defined over here, but that is the output of the model that I'm getting. Okay, next, once I have my model, okay, I'm still not trained my model, or basically I've not fitted my model to the data that I have. My data is still there. Which is my data? My data is still there as X and Y, where X ranges from 0 to 10 and Y follows this particular equation 2X minus 1 and 2X almost equal to 2X minus 1. Okay, it follows that particular equation. So given my data X and Y, the next thing that I need to do is what? I need to separate my data into a feature matrix and a target array or a target vector. Now, I already have my data separated, right? If you look at this, I already have my data separated. So X is an array of values ranging from what 0 to 10. Y is also another set of values. So I already have my data separated. But one more thing that I have to look into is my X, okay, or my feature metric should be a matrix itself. It should be two-dimensional. Okay, but if I look at the shape of X, okay, if I look at the shape of X, so I didn't run these code. Let me just run these codes once more. Yeah, run this. Let's import linear regression, build up my model. Okay. And if I look at the shape of my X, you can see the shape of my X is basically a single dimension, right? It is single dimension. So I need to reshape this or change the shape such that it is two-dimensional. To do that, I've used a NumPy technique using slicing. Okay, I've created my new X. This is capital X is equal to my small x. I'm slicing the whole in my first dimension. That is all my values in my first dimension. And in my second dimension, I'm adding a new axis, a new dimension in my second dimension. Okay, so by performing the slice, I'm creating a new data called capital X, where the shape is 50, comma 1, which is basically two-dimensional or basically a matrix. Okay, 50, comma 1. Now, Y, it should be an array itself, so it should be single dimension. So Y, again, it has 50 samples, so it is a single dimensional array. Okay, finally, let's fit the model to it. The fourth step is to fit the model. So I have my model, I have my data. Next is to fit my model based on my data. Okay, so for that, I call a function called fit. As the first parameter, I give my feature matrix, and the second parameter, I provide my array, the target array or the target vector. Okay, so once I've done that, now I have a model which uh, which is based on the data which I have. Okay, I build a model based on the data. Now, how can I make sure that my model is correct or not? Let's look into certain internal computations that will happen to build a model, and certain parameters of a model can be extracted. Okay. For example, model.coefficient is basically my slope. So it is 1.97, so very close to 2. That is exactly very same to the actual model that I have, right? My actual model that I had is what? 2. So 1.97 is very close. So I've got a model which is very close to my actual data. Now, since I have this randomness of my data, that is why it is 1.97. So if it is, if that randomness is not there, my model will find a coefficient as exactly 2 itself. Similarly, the y-intercept is also can be retrieved using model.intercept underscore, which is also very close to -1. -1 is my y-intercept. You can see my y-intercept of my model is actually -1. Okay, so that also I've got. Okay, I got my y-intercept also. Okay. Now, the last one is how do I make my predictions? Okay, to make my predictions, I've created some test data set, again, ranging from 0 to 10. So -1 to 11. So it ranges from 0 to 10. I've created some data. Okay. Line space, I've used line space and created some data. I'm calling this as X test. Okay, so this is certain data points starting from -1 up to 11, certain data points. Now, what I need to do is for each point, I need to predict Y. What is the actual value, the predicted value of Y based on the model which I have built, based on the model that I've built. Okay, so again, the shape of test is again, I'm going to have 50 different samples of my shape. Okay, 50 different samples for my shape. And it is again a single dimensional array. Now, because of this, again, the same thing. It's single dimension. Because it is single dimension, I need to convert this into a multi-dimensional, the same way that we have did while building our model. So I've converted it into multi-dimensional by adding a new axis. And then what I do, I found my y values for this test data by using my model by calling a function called as predict. So predict of x underscore test will create my model. Okay, this would create my model. Let me just run these files. I think I have, yeah. Okay, so this will predict my model. And finally, just printing what I have. Okay, this is the actual data and the line which I've got while testing. You can see the line is actually going to a straight line which is passing through all the points. It's the best line possible between all the points which is there in my data. So using linear regression, I can make make such predictions. Okay, now let's look into some realistic data. Let's look into some realistic data. Okay, now for this realistic data, I'm going to use a data set again within Scikit-learn itself. Now the data sets provided within Scikit-learn or Seaborn are only for evaluation or educational purpose. It's not for actual model building purpose. For that, you need much more larger data sets. For example, of the data set which we have for iris has only 150 samples, right? For iris, it has only 150 samples. Similarly, the datasets which are available in Scikit-learn are a little more larger than what is available in Seaborn, but still it cannot be used for actually real-world production environments. For that, you need some real-world data itself. Okay, so similarly, we're going to use a different data set within using Scikit-learn data sets library, Scikit-learn library itself. So if you go into Scikit-learn, again, if you go into data sets, okay, you have various different data sets. I've chosen one data set called Fetch California Housing. Okay, so if you look at this, there are around 20,000 samples. Okay, dimensionality 8, that is 8 features. Okay, 8 features. So 7 actual features, and 1 is a target value. Okay, all are real values. Real values. The target value ranges from 0.15 to 5. Okay, so the target is basically the pricing of the house. Okay, so your what the different features, the data features. If you want to describe what this data set has, let me first import this data set. To import a data set, I use Scikit-learn datasets import, and then I create I call this function called fetch California housing. This will return a data set like this. Okay, so housing, this will create a housing data. Now, one thing that is different from Seaborn is housing is not a data frame. If I go to and type in type of housing, okay, housing, you can see it is a different type of data called as bunch, which is actually defined inside Scikit-learn itself, which is built on top of a data frame itself. So it has some features of data frame, but not all the features of data frame. Now let's describe and understand what this data set is. Okay, so housing.describe describes this data set. So you can see it has number of instances, 20,640 different instances, 8 numerical attributes, which one of it is it's basically and 8 numerical attributes and a predictive attribute, which is the target. Okay, attributes and our target attributes. So what are these 8 different attributes? You have median income within a block, house age, average number of rooms, average number of bedrooms, the population, average occupation, the latitude, the location. Okay, these are the different attributes. There's no missing attributes for any of these values. Okay, and the target attribute is nothing but it is the price. Okay, the idea is to predict the price of a house given these attributes. Predict the so the target variable is basically the value of that particular house. So that is expressed in terms of hundreds and thousands of dollars. Okay, so here, if the value is, for example, 0.1, then in that case it will be 0.1 into 100. That means it will be or value is 1. If the value is 1, then it is $100,000. Okay, so if it's 0.1, then it is $10,000. Okay, so depending on the value. Okay, so this is the target variable, and these are the attributes. So I have this data. Given this data, what can I do? Next, the first thing, let's go through the steps one by one. I have my data. The first thing that I need is import my linear regression model. Again, this is a regression model because I need to predict a continuous value. I don't know whether it is linear, but for now, let's use a linear example itself. Let's use linear because we have already discussed linear regression at a moment. Later on, we can look into some little more complex models, but for now, we use only linear regression. The second thing that I want to show you is I'm going to, instead of using two separate data for tests or using a separate data for tests, I can use the data set I already have, which contains what 20,640 examples, and split this data into two portions. Say 80% of this data can be used to fit the model, and the other 20% can be used to evaluate a model and test that particular model. And to split your data into two parts, okay, one for testing and one for training, we have a very convenient function within Scikit-learn called as train test split, okay, which comes inside the model selection argument. So what does train test split does? So my housing.data is the X value and housing.target is my Y value. I'll pass my X and Y values, set my test size as 0.2. That means 20% of my data from this, I'm going to take it for testing purpose. I'm going to use only 80% of this data for fitting the actual model. What does this function does it? It creates 4 different variables. A capital X train used to train my model, the feature metrics, okay, and a capital X, capital Y, Y train, okay, Y train, which is my target metrics while training. And my feature metrics while testing is X underscore test, and my target value while testing is Y underscore test. Okay, so this function can be used to make this split. Then the next step is using linear regression. Okay, using linear regression, I can use the linear regression model, fit that model to my train data and my X train and Y train. Okay, once a model is there, then I can create predictions for the different test values. Now, we have not discussed how to evaluate the model. We'll do that later on once we discuss the evaluation. For now, I'm just going to take one value from my test data and predict and see what it is. Okay, so for example, I'll check example data is equal to X under the first value from my test data. Okay, reshape it. Again, my test data is an one dimensional, so I'm reshaping it using a reshape function. Okay, into a two dimensional, 1 comma and -1 is how much our features that I have in X. Okay, so I'm reshaping that into that, and then what happens after reshaping? I'm using my predict function. So model the predict, I'm going to give my example data. That is the first value in my test. Okay. And this will predict a value. Okay. This will predict my value and we can see the output over here. Let's see the output over here. So for this particular example data, the predicted value was 0.7191. Okay, now if I want to find the actual value is basically Y underscore test of 0. Okay, you can see it is 0.477. So it's much far away from the actual value. Okay, so linear regression is not the best model for this. Okay, you can perform very others or maybe tweak your hyperparameters and do other things. You may get a better results, but you can see the predictor value and the actual value differs a lot. Okay, let's try for a different data. Let's try for say 100. Okay, make a prediction for that. So the predicted value is 1.5. So for 100, what is the test? Again, it is differing quite much. Okay, so the model has not learned that. It's not the best model, but still, this is how we can make. So the idea of here is how we can make use of one of the libraries which is there in Scikit-learn to make some predictions. Okay, now this is a very complex data. This, what to say, housing model is a complex data. You cannot fit this using a linear model because it has multiple features. It has 8 different features, and it is a much more complex model. So you need to go into a polynomial regression. Okay, a little more complex. Your model should be a little more complex than just a straight plane. So in this case, it'll be a straight hyperplane, not a plane, it'll be a hyperplane, a flat hyperplane. So it should not be, it should be a much more of a surface, a complicated surface, a much more complicated model. And for that, we cannot use linear regression when in such a complicated data set. Okay, if it is a very simple data set, linear regression. Only because we have discussed only linear regression up till now, up to the last class, we have used linear regression. In the next class, we will move into classification modules and some other modules, and then we will come back to some data sets within Scikit-learn. There are many other data sets. For example, the iris data set itself is there, where which we can use again 150 values. We'll see whether we can make some predictions based on the based on the data that we have. Okay, so that's it with this class. We will look into other classification models in the next class. Clear? Any doubts?
Clear, sir.
Okay. So thank you then. We can wind up today's class then.
Thank you, sir. Good night.
Okay,
Thank
good
you, sir.
night.
Good night.